Okay, an important error correction. I couldn't see the error when I did this, because once you get into an error of this nature, you never get out of it. I had to think this through a couple of times. We're integrating the curl of f dot n with respect to area over the unit circle. And the curl of f we calculated to be -2, so we got -2 times the integral over the entire circle of the area increment. And that integral, of course, has to be the area of that circle. It's a unit circle, circle of radius 1, centered at the origin. So we're going to get -2 times the area of the circle. And I wrote down 2 pi for the area of the circle. Because I had 2 pi in my mind, I knew we were going to come out with 2 pi. And figured that out back here someplace. So I wrote down 2 pi, and then I multiplied that by -2 to get -4 pi. Didn't think any more about it. Went on and did the circulation integral around the circumference here, and I got -2 pi, and that wasn't equal to -4 pi. And I said, well, these got to be equal. You know, this is Stokes' theorem. Okay, I didn't, and I said I'm going to have to look at that some more. I don't want to take class time to reconcile it, but clearly one of these is wrong, and I suspected it was this one because this one came out in a very straightforward manner. And of course I was right. When I wrote down 2 pi for the area of the circle, it's not 2 pi. The area of a circle of radius 1 is pi. Okay, so I should have had pi there instead of 2 pi. Now it came out -2 pi, agrees with this. So there's an error correction. Don't make errors like the one I made there. Think through everything you write down, and let me make the mistakes, and so you don't have to. Okay, so that's an error correction, just a brief error correction on a calculation that was done here. Now I'm going to go through the whole thing in the next video, but I didn't want to make you have to go through the whole thing to see that one error correction.